This is an example of completing the square starting with the quadratic trinomial. In this case, we'll do two different examples. The first, we'll start with a case where the leading coefficient is a 1. So let's go with x squared plus 8x plus 13 equals 0. The process of completing the square is a matter of thinking clearly so that you don't write x cubed instead of x squared. Is a process of writing the quadratic trinomial in such a way that the trinomial can be grouped into a binomial squared. Now, side note, if we start with x plus a squared, if we go ahead and multiply that out, you can, depending on how comfortable you are doing this in your head, you can skip this step. But if we use the distributive property, more popularly known as the FOIL method, in which case we multiply first, outer, inner, last factors, then in this case we have x squared plus ax plus ax plus a squared equals 0. Here you'll see we have x squared plus two of those ax terms plus a squared equals 0. And what's important to notice here is that the a is half of 2a. So what we have here is half of the linear coefficient squared. Come back up here to the top for a second. If we take half of the linear coefficient and we square it, half of 8 is 4, squared is 16. Now, we need to add 16 to both sides. Okay? In which case, what we have here is x squared plus 8x plus 16 equals 3. But the whole reason that we did this was the whole reason we made room for this plus 16, which is called completing the square, was because this is now equal to x plus 4 squared. And that's equal to 3. The beauty of this is, if it's written in this form, if we take the square root of both sides, we know that this can be plus or minus the square root of 3. Now if we subtract 4 from both sides or add negative 4, this is negative 4 plus or minus the square root of 3. What does that tell us? This is a parabola. The vertex is located at x equals negative 4. This is the center axis of symmetry, the vertical axis. And then the x-intercepts are at negative 4 minus square root of 3 and also at negative 4 plus square root of 3. That's where you have your x-intercepts. Back to the crux of the problem. The business of completing the square is starting with the quadratic binomial, making room for the term that allows us to write this as the square of a binomial. That's completing the square.